by saying. Okay, so when you put a polynomial in standard form, you to put that in the decreasing power of x. You know that, correct? So x raised to n, x raised to n minus 1, and like a decreasing power of x. Highest powers come first, and then you go from left to right in the descending order. So degree is the power of the term with the greatest power. So degree is, remember, that it's with the greatest power. So now this is very simple. So you have to put it in standard form. So when you put in standard form, 7x cubed minus x square plus 3x minus 9. And the degree of this will be 3. Correct? With two variables, the sum of the powers in each term is the degree. So what is the degree in this one? So basically 5 x cube y cube 6, then the degree will be 5, correct? Then the degree would be 4, correct? Then there's also one more with degree 2 over there, which we missed, with 4. Yeah, this is also with 4. This is also with 4, so that's fine. And then you have degree 2. So what is the degree? Overall degree 6. 3 plus 3. 3 plus 3 is 6, yeah. 3 plus 3 is 6. So example of this, fx is equal to, so when you're looking at fx is equal to minus 14, correct? Degree is 0. It's a constant term. When the degree is 1, it's linear. Correct? When degree is 2, it's a quadratic. When degree is 3, it's a cubic. And when degree is 4, it's a quartic equation. Okay? So when you ask to evaluate, you should answer, think of an answer as a number. Evaluate. Direct substitution, so you know already what to do. You just put 3 directly in this. But how do you do synthetic substitution? Suppose you want to do this with synthetic substitution. You know how to do it? Can you do the first 2a and send it to me? Yeah, please do that. So let me do it for completion of this page. 3, 2, minus 5, 0, because the x square is missing, no? Yeah, correct. So 3 2s are 6, 1, 3 1s are 3, 3, 0 plus 3 is 3, 3 3s are 9, 5, 5 3s are 15, correct? 15 and 8 is 23. Correct? That means that means your f of 3 is 23. Similarly, this one also you can do it. Okay, fine. Synthetic substitution is coming over here. Okay, try this one. 3b. Yeah, I think so. Because of that, you made a small mistake, it seems. I'll tell you what you do is take only the coefficient minus 1, correct? 0, 5, x square is 0, 3 minus 2. Please space it out. That's very important that you space it out. Half. Now first you carry this minus 1 down. First thing is you have to just carry this down. And then you multiply this with this. Correct? So that's minus half. Add minus half. Multiply minus 1/4. So what is 5 minus 1/4? 5 4s are 20. 19 over 4. Multiply 19 over 8. Add this 19 over 8. Multiply 19 over 16. So 16 3s are 48. 48 minus 19 is how much is that? What is 48 minus 28? 48 minus 20. So 28, correct? So what will it be? 29 or 29 over 16? Because you're subtracting 19, na? You're following that? Fine. Then this will be, how much is it? 32? 29 over 32, correct? So 29 over 32 minus 2, LCM is 32, 29 minus 64, correct? So how much is that? 64, 29, 9 and 5 is 14, correct? 35. Yeah, minus 35 over 32. Did you get that? End behavior of a function. Now the end behavior of a function literally means the end. You look at the end of the functions. Correct? Refers to behavior as x approaches infinity or minus infinity. The figure shows a graph of y is equal to minus x cube. If you see the end behavior, as x goes to infinity, your function will go to minus infinity. Means it's going further and further down. And as the x goes to minus infinity, yeah, minus infinity, y goes to infinity. Yeah, yeah. So this is how you write basically in short. Approaches means you put this arrow. This arrow means it approaches. So use your calculator to graph the following functions and giving the end behavior. So you did this in school? This was easy, no? Okay, now if you do this, you can get a general rules for the behavior of the graph. When your degree is positive, leading coefficient is, or degree is odd and leading coefficient is positive, what happens? So I to remember one example. I remember when y is equal to x cube basically. So y is equal to x cube is like this. So as your x goes to infinity, y will go to infinity, correct? And as x will go to minus infinity, y will minus infinity. Degree is odd and the leading coefficient negative. So you can just remember one example like this, correct? So this will be minus x cube. Yes. And as x goes to minus infinity, y is going to infinity. Even positive. So even positive, you can just look at this like this. So what can you say as your x goes to infinity? We are looking at this end. As x goes to infinity, what will happen to it? And the other end, so degree is even and leading coefficient is negative. So you can just think of your like this. So this is y is equal to x square, and this you can think of y is equal to minus x square. Y also goes to negative infinity. Correct? This is positive infinity. Yeah. So basically in odd functions, this and this will be opposite. The y are opposite. In even, the y are the same point. You know? Yeah. Yeah. Correct. Now, draw the graph by making a table of values, plotting the points, connect these points with a smooth curve. Use what you know about the curve's end behavior to complete the graph. Then check with calculator. You may split up substitution work within your group. You know how to do this. You put in these values and you do it. No. Listen, what you can in exams, if it comes, you can use synthetic substitution. Yeah, and do for each basically minus 3, minus 2. So suppose if I do one of them, 1, 3, minus 3. So minus 1, 3, 4, 4 threes are 12, correct? Because minus 9, 9 threes are 27 to 24. So this would be 24, basically. So do minus 2 quickly. And so on. Just do it skills. When you graph a polynomial function with a graphic calculator, you need to take some time to have a good viewing window. A good viewing window shows the main features of the graph. What are the features? Four features. It should show the intercepts, the x and the y intercepts, the turning points. It should show the end behavior and should show the general shape of the graph. Yeah, window setting. You know how to do that, no? Okay, so I think so. Again, this homework is from that.